Hello, welcome to the Energy Losses in Pipes F1-18 experiment. Today we're going to be talking about the low flow procedure. So the first thing you got to do, make sure that both of these two outlet pipes right here, when you first turn this thing on, there may not be water going through it. This is just because we were testing beforehand. Make sure that both of these pipes are draining into the side tank right here and don't have a significant height difference like this. If you have this too high, then we found it doesn't drain properly. So make sure that these are pointed in the tank where they can drain properly. To start off, set this three-way valve right here to the position that says direct from F110 bench. So you can see there's two arrows right there. We're going to twist it so that the arrows are facing this way and this way. Then come down to the actual hydraulic bench itself. Make sure this valve is fully closed, so all the way to the right, clockwise. So we'll turn it on, but no water should come through. And then make sure that this valve is fully open. So there's a plus and a minus direction right here. We've already got it fully open. You can see that there's some water that's starting to come through it. And if I increase the amount of water flow rate that's coming in from the direct hydraulics bench, then we can see.
I have to close this one. Okay, so now I got close.
Sorry.
No problem.
You can see that there's water going through the manometers there. Might be hard to see, but
We should make sure until it's completely full.
Yes.
And then we should switch the valve operation, I believe.
Yep. So once you've gotten all the bubbles out of the system and these two manometers look completely full, we'll change the three-way valve to be in a position for constant head tank.
In order to have the chamber full with water.
Yep. So give that a few seconds. And we should see once it overtakes the height of that gray pipe right there, that gray pipe will act as an overflow. So you're okay to leave the bench on. The overflow should take care of it. And you can see the water coming out of the large tube right here. This is just an overflow.
Very nice.
So not something that we actually need to measure. Okay, once you've got all of that going, what you'll want to do next is close your outlet valve here so that the only water that's escaping from the system currently is through the overflow.
To pressurize the unit.
Yep, so we're pressurizing the unit here all the way closed. And then we're going to decrease the amount of water going in. We don't want to turn the bench all the way off because we had some backflow issues. But keep it, like, go ahead and close the flow rate, just don't turn it off.
Yes.
So it's okay to have zero, but don't turn it off. So you can see the overflow is no longer overflowing because we're not putting any new water into the system. We're just maintaining a pressure at the inlet. So when you're ready to test, what you'll do is you should be able to open this outlet valve a little bit, and hopefully we'll see a pressure differential develop in these two manometers here. And if we don't, then we'll talk about a fix.
Oh, we should see now.
So as you can see, a pressure differential is not developing in the manometers. We need to let some water out of this system right here. So I'm going to attach this extra plastic hose to the bleed valve right here and very gently let some water out. And you can see as I do that, the manometer readings will be very clear. While I have this valve open, they're trying to develop a differential, so close this while you're doing your bleed valve work. I know I'm kind of jumping back and forth. Keep this closed, and you can see in both of our manometers right here, we'll reach some specific value. Those should be relatively equal while we have a no-flow style situation. So go ahead and let a little bit more water out, and it will jump around a little bit. We should let it get down to about
300.
300-ish. Let's see where that's at. Too high. Let me try to
Be careful, it might water come out now.
It will.
Okay.
It will. It's going to be a very small amount. I won't load it. Let's try the bicycle plane when I do.
So now Justin tried to reach 300 level equal. That's our ideal goal. So he tried to put some air with this pump into it, and then he tried to slowly open the valve here until we reach a 300 level, and he will going to continue from here what we should do.
Yeah. So again, just to recap, if you have a situation where this is too high, you'll have to do a couple things. Open this slightly, attach the bike pump to here, open the bleed valve, and very, very, very slightly give it some pressure. That'll flush additional water through the system.
Yes.
Once you get it close to 300 millimeters on both sides, it's a little low, but that's okay. That's pretty close to what you want it to be. Make sure this valve is closed, your bleed valve is closed again. Students will then get a hopefully cleaner beaker than this one.
Exactly.
And place the small outlet tube into that beaker.
To measure the flow rate.
Yep. And you want to use a small one, you don't want to use a big pitcher because the flow rates are very small. So to actually take a reading, you'll have them open this valve a little bit.
Until
and we'll
you see the pressure changes.
Yep, we'll see a pressure differential develop between H1 and H2
And then-
right there. And at the same time, water is starting to very slowly come out of the
Exactly.
pipe right here. So one student in each group will do a stopwatch and measure
Flow.
delta volume over delta time to get flow rate. And one student will record the different pressures that they develop. Then we'll repeat this for a couple different flow rates. So this would be one data point. And the next data point would be
Again.
found by increasing the
flow
outlet
rate.
valve, which increases our flow rate,
Exact.
and thus the pressure differential developed. You can see that the difference between H1 and H2 is larger this time
Thank
with
you.
a higher pressure value.
Thank you very much, Justin.